Picking up where we left off with the modular arithmetic lesson, let's take a look at example 4. And 20x congruent to 16 mod 64, maybe the most immediate observation kids are going to make is that 20 and 16 are both divisible by 4. And you might wonder, could I actually simplify this congruence by dividing out of 4? You can, but this is where we go back to this previous property of division, where you are allowed to divide out a common factor, but you very well might change your modulus when you do this. You see, if there is a greatest common divisor between the modulus and the number g that you're dividing by, then you divide your modulus by that greatest common divisor. So, let's revisit number 4. And, of course, you want to divide by 4. Now, the big question is, what's the greatest common divisor between a 4 and a 64? Well, 4 divides into 64 and 4 divides into 4. It's going to be 4 itself. So what we're getting at is, can we divide by 4 here? Yes, you can. You're also going to divide the modulus by that number 4 as well. So this will become 5x. This is going to be congruent to 4. New modulus now. This is now going to become 64 divided by 4 is 16. Now, that's all well and good. And as we look here, hopefully you can see that we can definitely proceed now and look for another way to finish up this problem. As we look at the multiples of 16 themselves, you could say 16 times 1, 16 times 2, 16 times 3. You can notice if we're just continuing to add 16 each time, that's really what's happening. I think the really interesting one that we're about to get at is when we add 16 here. 48 plus 16 is actually going to get you 64, pardon me. I'm getting a little bit ahead of myself right here. But as we do that, I definitely want to point out to you that we want to have a remainder of 1. 64 is divisible by 16, so that would have a remainder of 0 if we took 64 divided by 16. But if we add 1 to that, we're at 65. And that's honestly where we want to go. So let's multiply both sides right now by 13. You might think, well, why are you doing that? Well, because now I'll have a 65x. 4 times 13 is 52. And like I just said, 65, when you divide that by 16, you will have a remainder of 1. And this just becomes a 1x. And 52, you can see, is very close to 48. It is 4 steps higher than 48. In other words, we'd get a remainder of 4. So this is how we can solve very quickly. Notice if we write our answer parametrically, we're now going to say 4 plus 16t. A very important distinction. Very much a similar setup with number 5. Maybe the very first thing that kids might notice is that 51 is actually larger than the mod. Mod is 36 here. And if you subtracting is always a friendly way, fast way to do this, you'd get 15. In other words, we'd have a remainder of 15 if we divide 51 by 36. And why do I do that? Well, you don't have to do that, but I do think it's an easier kind of an approach. You look at this right here at the 15 and the 21, and I hope you can see 3 divides into 15 and 21. Could we divide both sides by 3? Yes, we could. But as we look at that greatest common divisor between 3 and 36, we could see that would be a 3 itself. We're going to have to divide our mod by 3. So let's do that. We'll get 5x would be congruent to 7. Here's your new modulus. It's no longer 36. 36 divided by 3 is 12. Brand new mod. As you're looking at the multiples of 12, you've got 24. Your ultimate goal, though, is to get a remainder of 1. You want to be one step larger than one of those multiples. And look at the 5x. If I multiply both sides by 5, you're going to get 25x. 7 times 5 is 35. And this is mod 12. And, like I said, 25 is really just a remainder of 1 in mod 12. 36, well, is a multiple of 12. 35 would be one step short of that. If you're really on your toes, you're going to realize you'd have a remainder of 11. 35 divided by 12. 12 would go in twice, but the remainder would be 11. Otherwise, just keep subtracting 12, or subtract a 24 if you would, and you can see eventually you'll get a remainder between 0 and 11, and we see it's 11. How do we write our answer out parametrically? Simply as x is 11 plus 12t. And again, we could let t equal 0, t equal 1, t equal 2, t equals negative 1, negative 2. All of these numbers are going to arrive at equivalent integers that would have a remainder of 11 when we divide by 12. Last one, number 6. I've deliberately given you some problems where the modulus isn't a friendly number. It's a prime number of 29, and it's a little bit bigger. It's not the first time we've had a mod 29. But undoubtedly, this is something that can make kids a little uncomfortable, especially when you look on this left side of seeing a 17. 17, is not going to be divisible by 29. 29 would go in 0 times. We'd have a remainder of 17. But tell you what, here's a little trick we can do. Let's go ahead and just multiply by 2. And right now that might seem so counterintuitive at first. You might think, why in the world would you ever do that? Well, here's why. If we can get a smaller number in front of x, maybe, just maybe, that's going to help us out. 34, if you just subtract 34 minus 29, you get a 5. So what I'm really getting at is this coefficient of x is really equivalent to 5. And I'll tell you what, this becomes a much friendlier way to deal with the problem. If you can get a coefficient of, like a 2, a 3, a 4, or 5, that's so much easier to work with as opposed to a coefficient of 17. And if you look back, we've done that a lot for quite a few of these problems. But look, you look at the very first multiple of 29. 29 times 1 is 29. A remainder of 1, one step bigger, would be at 30. Right now, I could multiply both sides by 6. What do we get? 30x? Well, 6 times 12, of course, is going to get you 72. And we'll work that out in just a moment. Obviously, the 30, is one step bigger than 29. This just becomes an x. Look, if we kept adding 29, 29 plus 29, you could see that went up to 58. If we add 29 again, you can see that we're going to be at 87. Why do I bring that up? Rather than having to do long division, you could say, well, look, 72 is, close to 87. And it's between the 58 And that right there. Now, it can help you out in one of two ways. It can help you out in actually doing long division. You can say, well, it looks like we're going to have a multiple of 2 and, go 2 times 29 and actually get a 58. And then we can subtract. And, if you're really on your toes, however, you'll just say, you know what? I'll just subtract the 72 minus the 58, and I'll be able to know that I'd have a remainder of 14. And that might be a life-saving, quick kind of approach. Life-saving in the sense that when you're in a contest where you only have 30 minutes, sometimes you get overwhelmed by trying to do long division over and over again, especially if you have the unfortunate situation of having ugly numbers. But instead, you could just say, well, how far away is that 72 from, this nearest multiple? And then you're good to go. How do we write this out in another form? We could just write x is equal to 14 plus 29t, and we are done.